Here is your latest installment of algebraic structure. Now, before I even start here, make sure it's crystal clear. The purpose of what we're doing right now is to not solve an equation going through some kind of algebraic gymnastics to isolate the variable and find out that x equals something. The goal of these activities right now is to help you to see the algebraic structure that is inherent in these equations that you've probably seen in your past. So this activity that you did in class, we're going to start with a truth claim. In this case, I'm claiming, and we're going to take this to be true, that q equals 5. The variable q happens to equal 5 in this case. Now what we're going to do is, from that, we're going to build new equations. We're going to build this web. Hey, there's nothing special about this web that I'm building in terms of its structure or format. It's just a way to kind of build this, and it'll help us record what we're doing. So we're going to build this thing, and let's say, for example, I'm going to start by starting with q equals 5, and I'm going to make a new equation involving addition. This is an addition sign. So I might say something like this, add 2. Well, if I add 2, it would look something like this, q plus 2 equals. Now remember, the claim that q equals 5 is still true. I'm always going to have that claim. Whatever I do in the future, q still has to equal 5. Well, if q equals 5, then 5 plus 2 would be 7. So I could make the claim, if q equals 5, that q plus 2, 5 plus 2 is equal to 7. So this is just an activity, a task to make your brain think about the structure of the algebra. Hey, what if I kept going? What if I said I want to use multiplication now? Do whatever you want. No, I'll multiply by 3. So to multiply by 3 would look something like this. 3 times q plus 2 is equal to. Now, let's just pause here for a minute. 3 times the sum q plus 2. What would it equal? We'll come back over here. We've already claimed that q plus 2 equals 7. And we claimed that because q equals 5. 5 plus 2 equals 7. If q plus 2 equals 7, then this q plus 2 right here is equal to 7. So what this says is 3 times 7, because q plus 2 is 7. And 3 times 7 is 21. So now we have another claim that 3 times the quantity, as we say, q plus 2, which we know is 7, is 21. Now, just the way we did this in class was to have some different pieces of the web. Suppose we had subtraction here. Let's subtract 4. Q minus 4 equals. What would q minus 4 equals? Well, again, starting with q equals 5. Q always has to equal 5 in this world. If q equals 5, 5 minus 4 would be 1. And let's say we went over here and we wanted to divide. So q minus 4 equals 1. Let's divide by 6. So q minus 4 divided by 6 would equal. Well, let's figure this out. We've already claimed here that q minus 4 is 1. And the reason q minus 4 is 1 was because q equals 5. 5 minus 4 is 1. Well, now, if q minus 4 equals 1, then this is 1. 1/6. And we could keep playing this game as you saw in class, but I hope in just a summary statement here you see the gist of it. But what I want to do now is take one of these statements and just do some more work with it to see if you can track what's happening. So just as another task, let's pick on one of these. I'm going to pick on this one. Let's pick on 3 times q plus 2 is equal to 21. Let's pick on this one, and let's just do some more work with it. If I know this to be true, suppose I asked you for this. 3 times q plus 2 minus 5 is equal to. Could you figure out what 3 times q plus 2 minus 5 is equal to? The answer is yes. You can, because look, 3 times q plus 2, we already know is 21. So we already know that this is 21. and 21 minus 5 would be 16. So because we know something, we can answer different questions about this. How about this? What if I wanted you to tell me what 3 times q plus 2 plus 5 all divided by 4 would be? Now again, starting with this truth claim, can you figure out some other truths? Can you figure out some other equations? And the answer is yes. We know that 3 times q plus 2 plus 5, oops, I meant that to be a minus 5, so I could use that previous thing. 3 times q plus 2 minus 5, we know all of that is 16. Well, if all of that is 16, and I divide all of that by 4, I know that would have to be a 4 over there. So, again, starting with q equals 5, if q equals 5, then 5 plus 2 is 7. If 5 plus 2 is 7, that times 3 would be 21, and that minus 5 would be 16, and that divided by 4 would be 4. I'm going to have to play that little piece in slow motion to hear what I said. Now, the reason we do all this, and the reason you have the things in your homework, is to look at equations maybe in ways you've never looked at them before. I hope you're not looking at this equation and just seeing a bunch of symbols on the page. I hope you're looking at this equation, maybe in your head you're even grouping some things together, like you can see this q plus 2, and you can see that that q plus 2 has been tripled, and you can see that after you tripled q plus 2 you subtracted 5, and you can see that after you tripled q plus 2 and subtracted 5 and divided by 4, you got 4. If you can see all of that in terms of the structure, if you can see those different pieces, I promise when we go backwards, here's what's going to happen. Here's what's going to happen. The next thing we're going to do is we're going to start with things like this, and we're going to try to figure out that, watch this, what if I went from here, back to here, and ultimately back to here? Could I find out that q equals 5 if I had started with something messy, so to speak, like this? That's the goal, but that's not yet. For right now, I just want you to get your brain to see algebraic structure.